Let's solve some of the first question under the steam power station. So we are given the question says, the Shiroro Hydroelectric Power Station has what? Has the catchment area. So therefore we are given the area as what? As 5 times 10 to the power of what? Of 9 meters squared. Mean the head. It says mean head of 30 meter. So the height, let's say the height, which is what? Which is 30 meter. Annual rainfall of 1.25 meter. So therefore, let's say the annual rainfall, which is 1.25 meter. Yield factor K of 80%. So K, which is the yield factor, which is 80 what? Which is 80%, and that 80%, if I am to convert it, is the same thing as 0.8. Overall efficiency. So the overall efficiency, it is what? It is 0.7. It is 70%, but we have to convert it. And load factor of 40%, and the load factor, so I have to say the load factor. Let me just say LF as my load factor. So it is 40%. It is 40%. And find the average power. So we are to find average power generated in the power station. And also we are to find the rating generation installs. So we have to first find the water volume per year. The water volume per year, V, is the same thing as what? As AFK, which is the same thing as A, which is the area, 5 times 10 raised to the power of what? Of 9, and also multiply by the F, which is the rainfall, which is 1.25, and also multiplied by what? I have 0.8. So the water volume per year will now be 5 times what? Times 10 raised to the power of what? Of 9. Of 9 meter cube. So the next thing that I'm going to do here is that I have to find again the mass of water. So what will be the mass of water? Mass of water is the same thing as rho V. So I have already find the value of the V. So I have to say what will be the density of water. Density of water, as usual, it is 1000. So I have to multiply by 5 times 10 to the power of what? Of 9, which is the same thing as 5. I will just add the powers. Let's say the power of what? Of 12 what? 12 kg. So the next thing that I'm going to do, I have to find what? I have to find the energy available. So energy, it is the same thing as what? It is the same thing as mgh, and then multiplied by the overall efficiency. So this is the same thing as I have mass, which is the same thing as 5 times 10. I already find the mass. This is the mass. So 5 times 10 raised to the power of 12, and also multiplied by G, which is 9.81, and also multiplied by H. As you all know, my H, it is what? This is my H, which is 30. So multiplied by 30, also multiplied by the overall efficiency, which is this as 0.7. So what will be the solution of this? So the energy available will now be equals to, I need to have some space. So the energy will now be 1.03 times 10 raised to the power of what? Of 15 joules. So the question asks, we are to find the average power generated in this power station. So I have to say the average power. Let me say that the phi average it is the same thing as E divided by what? Divided by 365 multiplied by what? Multiplied by 24 and also multiplied by 3600. Someone might ask, how did we get this? You have to take note of that. It says meanwhile of what? Of 30 meter annually rainfall. So 365 days is the number of days in a year, and 24 is number of hour in a day, and 3600 is what? Is the number of second in what? In 1 hour. So I hope you get it. So after then I will say the average will now be equals to 32.7 what? Megawatt. So this is the average power in this station. The next in this power station. So the next says that the rating of generators installed. So we have to find the generator rating. So now let's say the generator rating. The generator rating will now be what? I have to first say the load factor. The load factor is the same thing as what? As the average power divided by what? Divided by the rated power. So therefore I will now say the average, which is 32, which is less what I find already, will now be 32.7 divided by 0.4. Because the load factor, it is 40%. So therefore this will now be equals to 81.8 megawatt as what? As my final solution.